I'm going to be talking about the new technology of voice control in products. And I want to do a shout out to Amazon, thanking them for leading this field and really finally making audio exciting again. I lived through the days when we went from 5.1, and then after that came 6.1. And you know what came after that? 7.1. So we kind of had 2 decades of very little innovation in audio. And thanks to Amazon, we have this exciting new field called voice input. A little bit about DSP concepts. What we are is we're a startup that provides technology to audio product developers. We work throughout the supply chain. So we work with chip partners, with OEMs, with system integrators, and provide key technology enabling them to build great audio products. We have a presence in both consumer and automotive markets, and we're backed by some of the great investors kind of wishing us success, helping us to succeed. The key technology we have is a product called AudioWeaver. The way you can think about AudioWeaver is it's a framework for audio product developers. Maybe you have a team doing machine learning and they're probably using TensorFlow or PyTorch or a framework like that to enable them to work more efficiently with machine learning. Nobody starts from scratch in a field like that. Similarly with audio, we kind of want to move audio into the 21st century and say, look, you don't need to start from scratch. Start with AudioWeaver. It's a general framework. It can be used to develop core technology, design new features, integrate them into products, and then finally deploy in the field. It's a graphical tool. So it's kind of like a low-code environment. So it can be used by people who aren't programming experts or signal processing experts, and also enables real-time collaboration between groups and gives developers access to kind of pre-tested off-the-shelf features. What we're seeing is demand for voice technology is really skyrocketing. So it started out with a whole bunch of consumer applications for the technology, and we've seen these things invade our homes, our cars, and so forth. And what's also happening now, really driven by the COVID, is there's a strong demand for this technology in point of sale devices, industrial applications, and so forth. I'm reminded down the street from me, there's a McDonald's. They installed a touch screen about 18 months ago. So instead of ordering, going up to the register to order, I could place my order using the touch screen. And pretty soon I realized, like, hey, how many people have touched this touch screen before me? Why can't I use my voice to do the ordering rather than have to go and touch this device? Same thing can be said for a lot of point of sale devices. Maybe you're buying a subway ticket or other things. And so that's really where I see the next wave of the technology coming. And in order for them to work successfully, we need to solve a variety of problems still. So inside of technology, these voice products, there's a lot of different technologies, okay? At the start is what's called an audio front end. So this is a suite of algorithms that it allows the microphones to basically clean up the environmental noise and feed a clean signal, first to the voice trigger, where you wake up the engine, and then also to a voice services integration. That's really the speech recognition system. And finally, there's more demand also for voice calling features. So I want to be, instead of just talking to the machine, like to talk to other humans. The algorithms that make up the voice front end, there's acoustic echo canceller that essentially eliminates the loudspeaker sound, because the loudspeakers are usually very close to the microphones. Next up, we also provide what's called an adaptive interference canceller. So I want to eliminate background noise. Maybe there's an air conditioner in the room, or maybe there's a TV playing that I want to be able to ignore. And then there's other noise reduction technologies. Beamforming combines multiple microphones. And finally, you also have to estimate where's the person standing. So let's go through now and let's talk about common facts and fiction and try to debunk some of the most common voice control myths. First thing I see is a lot of people are pushing more and more microphones, and performance usually tops out after about 4 microphones. That's usually sufficient for most consumer applications. And after that, you get diminishing returns. If you're in a really noisy industrial application, maybe you'd like to have more than 4. But for the most part, your home environment, your car environment, 4 microphones is just fine. Another thing people think is machine learning can only be used for the wake word and for event detection. In fact, this technology is leading to innovations in a lot of the audio front-end processing. Okay, can you tell a person's talking? Can you help distinguish speech from noise? Can you help eliminate background noise from video conferencing and so forth? All those innovations are driven by machine learning, and expect to see a lot more of this in the coming years. Another thing people think, consumers only want to use the voice assistants with smart speakers. In fact, anywhere you have a user interface right now is where it'll benefit from voice control. In fact, the more complicated the voice interface is, the bigger the benefit from doing voice control. Can I search and select movies with my voice control? Find new music to listen to? Can I control my microwave oven and so forth? All of these are great places to deploy this technology. Another misconception is it only works in ideal or quiet conditions. Okay, we all know that home environments can be far from quiet. And it turns out with the right audio front end, you can essentially get this technology to work in these environments. Okay, maybe you had kids running around with the right audio front end, the experience will be really good, and you'll get consistent voice recognition even in these noisy environments. Okay, for a lot of people, they think adding voice control is risky, and it really doesn't have to be. It doesn't have to be. What you can do is you can work with a vendor who has a technology ready to go, or you can base your design off an existing reference design. And the reference designs have all of the microphone technology, all the processors integrated. So you'd be integrating more of a module rather than starting from scratch. Another change that's happening is it used to be you could only work with one voice assistant. So at the beginning of your product development, you'd have to select which one you want to work with. Turns out things are starting to loosen up. This is also being led by Amazon. They have a voice interoperability initiative where they allow you to support multiple assistants, each one geared for a specific task. So maybe there's one assistant for managing your recipe books and helping you with kitchen tasks, another one for getting news, another one for playing music and so forth. And this is just starting to happen. And then we're going to see more products announced in the next year. Another myth is people think that in order to build a voice controlled product, I need to have a large internal team that's expensive and complex. And if you take your cues from Amazon and Google, you'll see they all have giant teams geared to this. Turns out you can actually save time and money. You don't need a gigantic team. If you start with the right framework and the experienced vendor, they can provide the building parts and then customize it to your particular application. Another myth is people think that the ASRs, that's the speech recognition engines, are getting so good that you don't need to have an audio front end on the device. Turns out you still need an audio front end to get the best performance out of it. The way I like to explain it to people is the audio front end is like a pair of glasses. Okay, suppose you're doing image recognition. Would you feed a blurry picture to your image recognition system, and then you would just train it with blurry images? No, you would do much better off if you fix the blurry problems. And so the audio front end is like glasses for your product. It gives clear data and allows the voice recognition to work well in a variety of different products. Another myth is that sort of one size fits all. I can take the same audio processing and use that across many different product families. What's interesting about audio is that each product is unique. You might have a different industrial design, form factor, environment it has to work in, different performance metrics and so forth. And each of those requires customization of the audio front end and individualized processing for your product. Let's switch gears now and let's look at what's coming up for voice input. What are the new fields and challenges that are going to be tackled? First of all, voice input is going to be standard in a wide range of products. So pretty much anywhere you have a user interface, there's going to be a voice front end. We're seeing this in appliances, and I can't wait for this to happen in automotive. Okay. Right now, typically, if you have your phone mounted on the dashboard, that's not going to work well for a voice assistant. What you need is you need it integrated into the car. And right now where we're at is it's still push to talk. That has to be fully natural with a wake word, and just the same experience we have at home, we have to get in the car. And then on and on and on. All these products are going to benefit from voice UI. Another thing we're seeing is greater emphasis on voice communication. So this is a feature in these voice controlled products, and this is going to become even more important. Okay, we're all stuck at home doing video conferencing, and I think that's going to continue for the near future and even accelerate. And people are going to want to do this for work, for home, to keep in touch with friends. We all do a weekly family Zoom, keep in touch this way. And the technology also has to work when you're on the go. So this voice communication feature is going to get more and more important. We're also seeing improved wake word algorithms coming. So lower false alarms so it doesn't accidentally trigger when you didn't say it. They're going to be working better in noisy environments. A lot of this is driven by ML technology. They're also going to work better with different accents. You don't just have to be a native English speaker to use these products. We're also getting fully branded and customized trigger words. So a lot of other brands besides just Amazon and Google are going to be jumping into the fray. And they're also adding voice authentication. So my personal assistant should only work for me. And so we're getting to the point where we're going to be able to kind of train the assistant to recognize my voice, and it'll only work for me. Kind of building upon this, we're going to end up with a more tailored user experience. Okay, maybe we can determine spatially where the user is speaking and address them personally. Maybe it'll recognize my voice in a group conversation, and it knows when I'm speaking, and it knows the history of my interactions with the assistant, and be able to provide a tailored experience. So this will take it to the next level, where there's going to be history, state information, and a much better experience, more like talking with a friend. Another change we're seeing is a lot of the processing now is moving from the cloud to the edge. Okay, in the beginning, the algorithms were so complicated, they could only run in the cloud. Advances are letting them run on the edge. This is also helping with people's privacy concerns. So instead of having to send all the data to the cloud, I can process it locally. It also enables non-connected devices. Maybe I'm driving my car, I can't always be near a city with good cell phone connections. Out in the country, it still has to work. And it's also going to lead to lower cost systems where now I don't have to need the additional cost of a cloud connection to work. So these things are helping drive processing to the edge. There's also innovations with different processor companies as well. There's going to be ongoing improvements in algorithms. Okay, always on processing, so lower power consumption, better performance in noisy devices. Some products also don't have what's called a good reference signal. So maybe you don't know exactly the sound coming out of the TV. You have to be able to cancel that. And also support for multi-channel products like sound bars, TVs, automobiles, and so forth. And finally, there's also going to be an explosion of bundled solutions for easy, cost-effective voice deployment. We're working with a wide range of chip partners, making easy turnkey solutions, providing reference designs for different product areas. It may be TVs or set-top boxes, making it easy to deploy this to a much greater number of products. And these reference designs are going to be able to help companies save time and also guarantee performance, kind of pre-tested designs that are guaranteed to work well. Thank you.